Welcome everyone. How's re-event so far? All good? Let me start with a question. Who in the audience is using all three tools on the title? All three. It is a bright light, but I think 10%, 20%? That's great. Of the audience, who has a preference for only one of the tools? 20%. Oh, I would have expected more. Well, I'm not a big fan of a specific tool. I'm a big fan of all three tools. And earlier this year, I thought, hey, this is maybe a good topic for re-event this year. And then I received the news that I got to talk here at re-event about the three tools. So I started practicing and preparing, etc. And then I found out that there are so many angles, there are so many rabbit holes. And well, I did my best to select the right topics for today, and I hope you enjoy it. My name is Martijn van Dongen. I'm living in the Netherlands, near Amsterdam, 30 minutes north of Amsterdam. I'm working for a company called Schuberg Philis. I'm also an AWS hero. I started the community in the Netherlands in 2017, organized all the meetups and AWS community days. So that's a little bit about me. For today, I will start with a little bit of an evolution of infrastructure as code, so how it all got started. Then I will do a very rapid learning exercise of all the three tools. Probably, well, if I had it on regular speed, it would take 1.5 to 2 hours. So I put it on 4x speed, and I'm going to speak faster and faster throughout this presentation to fit in the 60 minutes. Then we'll cover some anti-patterns, so things that I've seen people doing when making the wrong choice or not even making a choice. And at the end, a conclusion with some takeaways. So this is the evolution of infrastructure as code. And it all started around 2011, 2012, when they launched CloudFormation. And there was the shift from I scripted everything in Bash towards using a tool called CloudFormation. A few years later, Terraform was launched in 2014. I was actually in a O'Reilly conference in London when Michio Hashimoto shared, hey, I built a tool and this is the first thing I will show you. And back then I couldn't have imagined what an impact he had with his Terraform. In 2018, CDK version 1 was launched and developers got very excited about CDK. And looking forward to, moving forward to 2023, where we are right now, 2024, there's a lot of choices to be made. Which kind of infrastructure as code tool, all the other tools, how can I choose the right one? If you look at the evolution of infrastructure as code, this could have been my script in 2010 of deploying a network, maybe an EC2. It looked like this. But every time I had to reuse the same script for my production environment, I had to go through all the script to change all the variables. So I thought, maybe I should put them on the top. So on the top of the file, there are some variables that I can declare, and later in the script, they will be executed, basically. So I used the same script for all my environments. Then I thought, maybe I can do it even better. So I create like a YAML file with some variables on the top, with some components, and every component will be deployed. So I'm moving my logic towards a script and config file to configure the whole thing. How does that work? First, you have the create phase. So it will read the template, it makes a plan, creates all the components, and write the output to a stage.json. Then we do an update, so we make a change in the template YAML, and the update will read the changes, execute those changes, and update the JSON, the state of JSON. And then finally, delete. It's not going to read the template, it just reads the state file, start deleting all resources until they are all deleted. This didn't happen back then. Luckily, I had CloudFormation when I started. But while preparing this talk, I was also delivering a Python training, and I thought, what could be a really nice exercise for my group of students? And so they actually built, well, a tool similar to CloudFormation or to Terraform. So now we're going to learn all the 3 tools in a very rapid learning exercise. So I created a imaginary application called Tick a Box. It's a very simple website where you can create a list, and on that list you can put your items like what you want to bring home from re:Invent, like souvenirs, presents for the kids, your AWS hoodie, you should not forget it. And the nice thing about this app, you can also share that list with others so that they can also tick off things. So for example, if you have a birthday party and you want to share your wishes list, you can also share this list. So it's not live yet. Hopefully I have some time around Christmas, and then I will let you know. I'm deploying this application not in a very typical architecture. So normally you would see things like an API gateway or maybe a load balancer with containers. I chose a bit different architecture where the users access CloudFront, and CloudFront will forward the traffic to a VPC. And then in the VPC, the Lambda gets executed, and it will connect to the database DynamoDB. It's not necessary, I know, you can put everything in the public cloud. But this architecture allows me to explain how I should organize my project. Basically, what can I share across other components, but also with other teams. If you look a little bit more in detail, these are all the resources you need to deploy to get the architecture of the previous diagram. So on the left top, all the purple ones, that all belongs to the network components. You have to all declare them, even if you're not a network expert. Below, you see DynamoDB, the table. On the right bottom, you have CloudFront. The orange boxes are tightly connected to the Lambda function. And on the right top, we also need some permissions. Throughout the learning exercises, you will notice what we all need to do to deploy all those resources. A typical organization that I have seen in my career look a little bit like this, where a group of people build some landing zone. Maybe on top of that landing zone, they also share some infrastructure, for example, a Kubernetes cluster, maybe an API gateway where you connect all your microservices, and then you have the workload teams on top. So keep this in mind while explaining how my project is organized. This is the typical organization that I have in mind while building all those architectures. And also at the end, why I would choose a particular service, a particular tool. When AWS CDK was launched, they also helped us a little bit with some acronyms. The L1, L2, L3. By show of hands, how many people are familiar with the L1, L2? Oh, not that many. Well, L1 means CDK is a programming language like Python, Node.js, etc., where in a L1 situation, you just define CloudFormation resources, but now in a different language. So it doesn't add that much value. To really get the value, you need to go to L2, where you have the more curated constructs. For example, the VPC, you don't have to define all the separate resources. You can just define one VPC, and it will create all those resources for you. And then you have L3, and L3 means we combine a couple of those VPCs, maybe gateway endpoints, etc., that are patterns for all your applications that run in your organization. And I thought, this is a really good idea. Why didn't we have that with CloudFormation and Terraform? And apparently we have. I was already doing this, but now we have a short way of naming those things, L1, L2, and L3. So if we look at the table, we now see the three tools on the left, where we have Terraform, CloudFormation, and CDK. L1 is basically the same for all those implementations. L2 means in Terraform we will work with modules. In CloudFormation we will work with a tool called Scepter and something that I will keep as a surprise. And for CDK we work with curated constructs, like they have in the documentation. For L3, for Terraform means we work with stack modules, so not only particular VPC but also a more comprehensive architecture. For CloudFormation, we can work with several AWS services. I will demo one today. And with CDK, we have patterns. I will start with Terraform L1. And if you work with Terraform, the first thing you need to do is define a couple of configuration items, like which provider am I going to use, what's the stack name that I can use in my complete project. On the left you see a couple of files. This is where I define some resources, the purple boxes on the left top, the VPC and the gateway endpoint. So I define a subnet, a VPC endpoint, and I need to attach them, connect them to each other. Then if I look at the DynamoDB table, also have to define everything. It's all well documented, so you will be able to find it. And also the Lambda function. And here you already see there are quite some components required for just a Lambda function. So what looks like just one icon in the whole architecture, I need to create a data object for the role policy. The permissions, also pretty detailed in a data object. So in this part of the Terraform code, there's nothing yet deployed. That will happen when we define a resource in row 41. So here we will define the policy as a resource, and that will actually deploy the resource. Also attach that, the policy towards the role, and then the Lambda function itself with a couple of configuration items. I need to attach it to the VPC that was defined in the VPC YAML. And I also want the environment variable of the DynamoDB table so that I connect to the right table. And this is the function, so I can reach my function via a public URL. And this is the whole CloudFront distribution. It's quite a large configuration, so this is the most simplistic one that you can find. And yeah, it will take a couple of days to figure out what are all the configuration items. If you make a small change, it will take quite some time to deploy every time. The first time I used CloudFront, every change will take 50 minutes to apply. So we're in a much better situation right now. At the bottom, you see the commands that I use to deploy my Terraform templates. So this is all done from my local computer, but you can also execute those commands from a CI/CD pipeline, for example, in GitHub, GitLab, GitHub, code deploy, etc. So this is just the L1, and this is basically the way you should not build your Terraform templates, your Terraform projects. The better way would be with L2. And before I show the demo, I want to give a shout out to Anton Koblenko. I'm not sure if you're here, but I just talked to you this morning. He made a lot of open source L2 constructs that we can use in our Terraform projects. So in this demo, I will start from scratch. I create a file, the main.tf. I define the provider with some default tags that I can use. the variable stack as well, so that I can easily find my resources. And I also want to have the region, basically when I'm deploying, that I can name my resources based on the region. And now I'm defining a network, and as you can see, I'm not using a resource or a data object, I'm using a module. And in the source, I make a reference to something that is available on GitHub. So Anton published all his modules there. And I need to provide a couple of configuration things, like the name of my VPC, CIDR block that I will use, which AZs it's going to be using, if I use private subnets, etc. Then a separate module for the VPC endpoints, where I make sure that I can access my DynamoDB table from my VPC. It requires a security group. In this case, I will use the default one and the endpoint for DynamoDB. Then the DynamoDB itself. So again, the tables, the table that I will use. Could be done in just the resource itself, right, the L1, but I like this a little bit more because it's easier to read and easier to use as a maybe non-experienced Terraform user. And then the function itself, with a name, a description, the handler, and the runtime that I use. I use a lot of Python. I'm a Python developer myself, and not really experienced with other TypeScript, for example. And I've put the Lambda function in a zip file online. So at the end of the presentation, I will share also all the source code, so you can find it on GitHub, and you can immediately deploy it in your own AWS account to test it out. So this was basically the L2 implementation of Terraform. So maybe take a look at how we can do it in an L3. And what I do is, what I've just created is the whole, the same implementation as in the first demo. But maybe we want to also share it across multiple teams, so that all teams can use the same implementation. And in Terraform, we work with modules. So what I do is I make a folder called modules, and in the folder modules, I create one which is called CloudFront Lambda, for example. And I copy all the resources that I had defined in my main.tf, put it in the new main.tf in the module, and then I can reference my own just created module. In this example, it's part of the same project, but that's not easy to share. But what you can also do is put it on GitHub, your internal GitHub, your private GitHub, or maybe on an S3 or several other locations that you can use to share your modules. You can pin it to specific versions so that people are not suddenly deploying a complete new architecture, that they actually first test it, for example. So now we've covered Terraform, the L1, L2, and L3. So let's take a look at how we do that in CloudFormation. In CloudFormation, we also start with a template YAML. You can also do it in JSON, but I'm a big fan of YAML. So, where I start with just some comments, which is only possible in YAML, for the list table, so I can define all the properties for my DynamoDB table. And it almost looks the same like the Terraform one, except the syntax, right? This is the YAML syntax. Then for the network, I'm just copying some code examples that I prepared. Create a VPC, the subnet, the route table, and the route table association. The VPC endpoints in the security group. I still can't move forward in PowerPoint, which is, I already put it on 4 times speed, but sometimes we have to sit out a little bit. So I also can catch some breath. That's also nice. And then finally the Lambda function. For the Lambda we need a role, quite some configuration. In particular if you're new to AWS or maybe new to our infrastructure as code, what would be a couple of clicks in the management console is already up to now we're at 140 lines of code and we're not even there yet, so we have to define a lot more resources. And actually here's the end of the video, so I skipped the CloudFront distribution, I think. Oh no, it's also there as well. So it's quite some code you have to write, 180 lines. So maybe we can, before I continue, CloudFormation, it's always one file, it's always one stack. There are some features in CloudFormation that you can use to separate stacks and to structure your project. But a lot of companies where I worked, they built their own tool to basically structure their projects, often called the deployment tool. There was also one other company who thought, hey, let's make a tool for that and open source the tool. And the tool is there. So maybe you've not heard of it yet. It's called Scepter. And with Scepter, we can structure our project a lot better than the default CloudFormation implementation. So we'll start with 2 folders. One is the config folder and one is the templates folder. So in the templates folder, I will put all my templates for the VPC, basically the network, for my Lambda, maybe for my CloudFront. And in the config, I will define how I will use all those stacks. So which one should be first, export some information to other stacks. So I can really nicely configure my project. And what's also great from this project is that I can put my templates on an S3 bucket, or maybe on another location. So they don't have to be part of my implementation that I have here. I can also put it online. And this way, we can basically share a best practice of networking, just like we did with Terraform, with L2, with the items that Anton created. So here you see the path pointing to the file on a local file system, but you can also put it in an S3 location, so you can share it across your teams in your organization, or maybe open source it for the rest of the world. I define some parameters, so I can have a config file for my acceptance and production in the same project structure, which is also really nice. And this is where I define the Lambda YAML and the DynamoDB YAML. And basically the YAML for Lambda should contain all the pointers to the VPC that you use, the DynamoDB table that is all created in separate stacks. And nice thing about this whole tool, you deploy it via the command line, just like Terraform, and it will create native stacks in CloudFormation. So you have all the benefits of native CloudFormation. So if something happens with the tool, or you decide to switch to a different tool, your stacks are still deployed, so you don't have to redeploy all your resources or do a mass migration. You can just reuse what you already have. And this is the little surprise. We can actually do the same thing, not with Scepter, but also with Terraform. So in this project, I have a folder called templates, where in the templates, the video doesn't show it, but there are templates again for the VPC, for the Lambda, for CloudFront, etc. And then I can create resources that point to those templates. including the input variables, like the parameters for the CIDR block, for the subnet CIDR block. And then I can create a CloudFormation stack for the database. Points to the DynamoDB table. One for Lambda. Have to define all the input parameters there as well. But here the same thing. So the template URL is currently in my local file system, but I could also point to shared template locations. So I can have, for example, a platform team who is responsible for the templates, keeps them up to date, gives them a nice version number, so that people can reuse what's already there. So they don't have to write their own Terraform code. They can just reuse what other teams have been using in their organization. So if you look at the diagram, how that works, on the left we start with some CloudFormation templates. The group maintaining that will put it in a Terraform module, and the Terraform module can be included in several projects. In this case, Project A, Project B, and they are responsible for the deployment to their own AWS environments. So this is the CloudFormation L2 implementation. You can do it with Scepter or Terraform, or build your own tool if you prefer that. But I would like to keep it simple. Let's also take a look at the L3 version of CloudFormation. CloudFormation. In this example, I will be using AWS Service Catalog. Anyone used Service Catalog? Yeah, see 2 hands. Oh, that's weird. The slide disappeared. I will record also this session again, and I will include a video, so you can also watch that a little bit later. Let's dive into CDK. Any CDK fans? Okay, that was the tool. Five of you. Here you see the difference between CDK L1 and CDK L2. It's difficult to spot, but there's 3 characters difference between the two. Of course, you also have to define quite some more configuration parameters. But the first one will actually create only the VPC itself, so you have to define all the other resources as well, while the one on the bottom of this example will create all those resources for you. So if you run a CDK sint, you actually see all those resources. I have a demo of that as well. So here we init the application, so you get a whole bunch of files. Only a few of them are important, like the demo stack in this example. I need to import some libraries that I will use. And here I can create my CFN VPC, where I define the CIDR block. And this is the only one that I will do in this demo. As you can see, it only creates one resource. So the only difference between CloudFormation native is that I need a tool and write it in a coding language like Python. And now I change it to ec2.vpc, so I removed that CFN part of it, define an IP address, run the CDK sint again, and let's now take a look at this new YAML. So it creates the VPC, all kind of resources that I normally have to write myself. They're all created. So 200 lines of code, reaching the 300 lines of code. They even deploy, as part of this thing, a Lambda function that will execute in the cloud a couple of things to apply some best practices. So they're already built in best practices. And you can also extend this with your own best practices to make it more secure and tailor it to your needs. So in the end, we end up with, 343 lines of code, probably even more. by just defining a very small piece of code. So if we create a whole project in CDK L2, we'll copy in all the libraries that I need. I tend to start with the things that I need first, like the DynamoDB table, so I can reference it later. The next step would be, for example, creating the VPC, so that I can also use that further on in my template. So this is how I usually structure my templates for demos like this. This is also an L2 item, so it's not starting with CFN table, but with dot table, as you can see. So that means it's an L2 construct, where you can write less code and it will generate more CloudFormation. So if you use CDK, it always generates CloudFormation, and that could get actually deployed via the CloudFormation service. So you don't have to run it from your local file system. You can actually use it just like you use CloudFormation. The gateway endpoints, and then the role. And even the role is also an L2 construct. So basically, the lesson that we can learn here is do not use L1 constructs. Go immediately for the L2, and hopefully if there are multiple teams using a similar architecture in your organization, then you could even go to CDK L3, which will be in the next demo. Sometimes you need a couple of what I found a little bit difficult in this part was, and it went very quickly, but to reference something on the S3 on the public internet, you have to define a new object and reference that object. That took me a couple of hours to do this. I'm using Terraform and CloudFormation a lot for a long time. For CDK, a little bit less. So as you can see, the whole project now is 522 lines of code, while I only had to write a couple of lines of CDK code. So if we think, hey, this is an architecture that I can reuse across multiple teams, I can copy basically all my resources that I defined in my project, create a new folder, for example, CDK constructs, where I create my function app or CloudFront app. You can give it your own name, where I paste all the same resources that I had in there. I have to change the class name and the construct of the class name. And now I'm back in my own project, so basically the implementation for Tickerbox, where I can reference, import the library I just created. There are best practices that developers probably understand how to share these pieces of code, how to test it, etc. So that's all on the left side. That will be taken care of for you. So you as a developer can mainly focus on which implementations should I use in my projects. So now if we touched all items, so Terraform using in all the three L1, L2, L3 constructs, CloudFormation and AWS CDK. So how to choose the tool that you like the most? It's basically a very simple step. First step is, do we want to use CloudFormation or Terraform? If you know that answer, then you can move to step 2. Do we want to use CDK or not? Of course, AWS CDK is for CloudFormation, Well, there's also CDK TF, which works similar to AWS CDK, but it generates Terraform code. And then finally, step 3, are we using or implementing it in an L1, L2, or L3 way? Where L1, I hope we all learned now, will take a lot of time, so should not be used. You can better go for L2 at least. And if you have commonalities with other development teams, you can even move to L3. Some anti-patterns that I've seen in my career. One anti-pattern that I saw was some people built Terraform code and made a whole application out of it. And this was actually the config file. So what you can see here is that they not provide just a few things like the CIDR block and an IP address, but it actually is the whole structure of your architecture. And this is an anti-pattern because there's only one person that can make a change to the whole project. That's the person who created it. So that's like often called also the hero, but in a negative way. So that's really an anti-pattern that I recommend to avoid. Keep things simple and scalable so you can learn from each other and also contribute to the projects together. Because otherwise you get these kind of situations where you have a fork and forget problem. So these are commits to my project. And at some point, I keep maintaining my own project and somebody else made a copy of my project, but they were not able to use it. So they basically forked it and forgot to merge back to my project. So we have two projects of almost the same architecture. And a little bit later, another group did the same thing. So we have in one organization, you have 3 implementations. Maybe you've chosen the right product, all CloudFormation, all L2, but you have 3 versions of exactly the same implementation. So how we can avoid this is in this very simple diagram. The one that is negative is red, so that, as you can see, which is too complex. So there's probably one maintainer, nobody else wants to use it. It's highly opinionated, so everything that is defined has a very biased approach, and that's not something that I recommend to use. It's better to make it more simple. So make it smaller, reusable templates, for example. Doesn't matter in which project, Terraform and CloudFormation CDK, and keep it well maintained. And by keeping it simple, also others can be taught how to use it and help you maintain it. And in particular, in situations where you're working for an IT partner, for a customer, where at some point you say, hey, this is something that we implement for the customer, but the customer can maintain it themselves. So you as an IT partner can go for the next big challenge that they as a customer were not able to solve. So you can focus on the nice projects, basically. The other one, it's also not really negative, but also more positive, is the complex things make it just more flexible. That's what like Anton did with all the Terraform modules. He just made the whole network architecture a very complex thing, very simple to use. Not really opinionated, it's just the network components that you would normally also define, but well documented and easy to reuse. And of course, the best of all worlds is keep it simple and keep it flexible, so you get really valuable, reusable assets. There are a couple of more anti-patterns that I would like to share. One is let the expert choose. So the problem often is with CloudFormation and Terraform is that the people who are choosing the tool are already 10 years using the tool. So they are at the end of this very steep learning curve. While the peers where you would work with, they're at the beginning. So they have to do a lot to come to that level where you are at. And if you're making a choice of a tool that is really hard to get, they will become dependent on you. So they will never start building something or improving something. They will keep calling you. The other one, which I also do not recommend, is let the fans choose. And an analogy could be if you are driving a sports car, you're on the market for a Ferrari, you will never look for a really fast electrical car, while it's faster, cheaper, better, sustainable, etc. So don't let the fans choose, right? If they work with Terraform for a long time, they forgot about all the nice things that they had with CDK and with CloudFormation. They will always choose for the tool that they're a big fan of. Another thing that I've seen in my career is that people building landing zones and platforms for their customers, they ask the customer to build Terraform or CloudFormation code, but they don't get access to the APIs of AWS. So what you as an engineer did for 10 years, build something, deploy it, figure out what works and what not, iterate on the deployment and then deploy it. And now you ask your customer, hey, you have to do it immediately right in a language you're not familiar with, in an environment that can break, etc. You're working against a black box. So always give them just a sandbox or playground where they can test their templates, just like how you did it in your learning journey. Over-engineering also happens a lot, where the platform team thinks, let's spend thousands of hours to make the best template ever. And then if you ask, why are you spending 1,000 hours in that single project? Yeah, because we are using it 10 times. Yeah, but if we spend 10 times 10 hours, then it would be only 100 hours. And you spend 900 hours more to make it more flexible. So also keep thinking about, do not over-engineer all the time. Yeah, keep things a little bit simple. Another thing also to remember is the risk concentration. I've seen companies choosing a single tool, and that gives some challenges, right? And this particularly for partners, for example, if they build everything with Terraform, and a customer approaches, hey, I want to do some business, I have a nice project for you, but it must be CDK, because we are using CDK all over in our company, and now you only support Terraform, for example. You limit yourself, and this is a risk for you as an organization, because you invest a lot of time in just Terraform, while the customers may be using different tools. Also on the side of talent, yeah, right? There are not enough engineers in the world to do all the work that is there. And if you specifically commit to a specific tool, yeah, you're losing a lot of talent. So I always recommend pick one, but also keep investing in learning the other tools as well. Number 6, the disregarding the human effort. What I always hear in discussions between how to choose between the tools is, yeah, this is the features of the product are often compared, but they always neglect to agree on that this is a lot of time to learn. We can make all those abstractions. We can centralize the development of those things. That's all human effort. It's basically how you compare private cloud to public cloud. They also often only check, hey, this is the things we have to pay for a compute and for my data center, and they forgot about all the things they get from public cloud out of the box. I think we have the same thing with choosing between these tools as well. In particular, the difference, for example, between Terraform and CloudFormation is in CloudFormation, the state is managed by AWS, super stable, while in Terraform, you're always responsible for the state yourself. You can put it in an S3 bucket to save some cost, or you can get a service from HashiCorp to put it in there. But yeah, then you also get a more risk concentration because you're again working with a third party. So you're introducing a lot of extra heavy lifting, which is not always necessary. And the final one, don't underestimate the knowledge gap. I think I explained it before, where the steep learning curve, where we are more at the end of the steep learning curve, and don't underestimate how much time it will take to onboard your peers when implementing. Time for some key takeaways. I have 3 for you. First one is think about how you use the tools. So more into the L1, L2, or L3 decisions. 2 ways to simplify. This is what I often use in my presentations. One is creating abstracts, but if you create abstractions, then you also make it more difficult for the user to support. So I'm more into sharing knowledge. So this is also why I'm on stage here and other events, just to help each other develop skills to, again, help each other so that you make it more scalable. So I often use the hashtag always simplify, or make the right thing the easy thing. So not force someone to use a thing that you built, but make it so easy to use that they think, I'm not going to invest time to rebuild it or reinvent it myself. It worked great the way you created it, so I want to reuse it. And the final key takeaway is that partners and customers are fundamentally different. So also keep in mind that if you make a choice for you as a IT partner, that could be a different strategy compared to, for example, your customer. As an IT company, we can build out-of-the-box solutions for example, landing zones that customers can greatly benefit from. And they can just choose partners. So a partner that built a very sophisticated landing zone based on Terraform, customers might think, yeah, I'm not going to reinvent this myself or hire a lot of engineers to build a landing zone, because then I have to also maintain it. While I also can get it out of the box from one of the partners that's already proven the great benefits of this landing zone. You often hear people say lock-in, and I was listening to some podcasts, and they actually have a different word for it, which is much nicer than using the word lock-in. Lock-in on a partner or lock-in on AWS. They talk about stickiness. So make your products and your service as compelling as for your customers, that they want to stick to you as a provider, and not that you lock them in based on knowledge or not sharing the knowledge or making modules that are only available when you're a customer. Share that with everyone, and they will stick around. Before I close, I want to highlight a couple of names. When I got the news that I was allowed to speak here, I asked around on LinkedIn, can somebody review what I did? I didn't have time to ask them for feedback. So this is actually my first presentation. Please send me your feedback. Use the apps that AWS provide, or send it to myself. The QR code on the screen is to my bio link. And on the bio link, you will find my LinkedIn, other social media, but also the repository where all the demos that I presented today are also there. I will keep improving them, extending them, processing your feedback. And you can also contribute, because it's on GitHub, so you can also use it there. Thanks, everyone. We have 10 minutes left, but I will move to have some lunch. So if you want to discuss a little bit further about these topics or maybe other topics, feel free to join me towards the lunch area. And otherwise, I wish you a very great reInvent the rest of the week.